All right, hi Aside, welcome to another course snippet video review, this time in 4A. Glad to have you all back. Today, given that this is one of the first course snippets of the quarter, I wanted to make a video connecting a topic from 3A here to 4A. So what we're looking at right here, if you remember, this is our GPCR pathway as it relates to olfaction. So we're going to talk today about how this relates to some of the topics we've been discussing in week one, some of the material and some of the stuff we'll go over, we've gone over in week one section and stuff that we'll go over in week two section. Okay, so before we talk about this and before we do a quick review, let's do a quick review of what we talked about in week one section and week one lecture. So this is my diagram here, a simplification of the neuron at rest, at a resting potential. So at resting potential, we have a high concentration of potassium inside, a low concentration of sodium inside the cell. A lot of this is facilitated by the sodium-potassium ATPase, as you remember. And the second component that gives us this negative 70 millivolt resting potential is the permeability of the neuron to potassium, sodium, other ions too, but we'll just focus on these two for now. So if you remember from section, at rest, the resting membrane potential, this neuron is more permeable to potassium. So there's more leaky potassium channels. There's some sodium as well, but relatively the cell is more permeable to potassium. That gives us this negative 70 millivolt resting membrane potential. Okay, so if the neuron wants to initiate an action potential, it will want to increase the membrane potential of the neuron to become very, very positive. So what we'll see later in section is around positive 40 millivolts. So if you remember from section, influx of sodium can increase the membrane potential, make it more positive, can depolarize the cell. At rest, the cell is more permeable to potassium, which is why we see it at a negative resting potential. But how can we make that membrane potential more positive? We make the cell more permeable to sodium. So what I haven't drawn here is there are a lot of sodium channels that are on the neuron, but they're just not open. Okay, so once they open, once something was open, then the cell once it becomes more permeable to sodium, it'll become more positive. Its membrane potential will become more positive. So the goal then, that we were kind of like alluding to, but didn't dive too deep into during 3A, was the goal of this GPCR pathway. Ultimately, it opens up a sodium channel, right? So really quickly, just to review, when you have some sort of odorant binding to this receptor, it's going to activate a G protein, activate another protein that's going to make CAMP. And critically, the CAMP can open a sodium channel so that sodium can enter into the cell, right? And once you have a lot of sodium entering into the cell's membrane potential becomes more positive, and with enough of this, you can maybe enact an action potential with other types of sodium channels. So that, like I said, we were alluding to that a lot last quarter, but we didn't necessarily give you all the context. Well, now you have a lot more of the context, right? So this is what we call a metabotropic pathway, where some sort of signal from something activates a pathway that ends up, with multiple steps, activating some sort of ion channel. Okay, so again, we'll talk about ionotropic pathways and the difference between the other two in section, but one benefit I want you to think of right now, remembering back to 3A, is this generation of CAMP. If you remember, we emphasized that this was like a signal amplification step, right? You can really ramp up the signal using this protein here by creating a lot of CAMP. So I've only drawn one CAMP activating this CAMP-gated sodium channel, but really the metabotropic pathways can activate several different CAMP-gated sodium channels by creating many CAMP molecules, right? That's signal amplification. So again, that theme from last quarter, signalification, is still relevant. And hopefully now you can see how everything is tying together. All right, thank you for your time, and hope to, or excited to work with you.